Welcome back, girls. Last class we have seen the viral marketing. If you people remember, because it's about 3 days that we had a class, a session. Today we will look into the mining news groups using the networks. I think all of you are aware of what news groups are. Okay, where you try to share certain news on a network. Okay, so how each one news isn't same all the time, isn't it? The news is about so many things, so it is a heterogeneous one. So you will be having the groups related to the news. Okay, so now here when we come back to this, web-based social network analysis is closely related to this web mining. So when we are looking into the web mining, we are focusing more on the news groups here. There, we will introduce two popular web page ranking algorithms. One is a page rank, that is how many, at what level it is. Suppose you try to search for something, and then within nanoseconds, you will be getting a list of links on the page one. Okay. Now, if it is appearing in the first link, we call it as it's having a high page rank. Okay, and that depends on how popular your web page is. Then when you say the number of hits, that is number of visitors to that web page also is considered. So these are the two algorithms basically to introduce how popular your web page is. Okay, which is proposed based on the fact that the link of a web page A to B usually indicates the endorsement of B by A. If I am visiting this particular web page, that means I am endorsing that web page. Okay, so how many are doing it, and what is the rate that is where it is standing, the rank of it. Okay, this is what we need to analyze. Based on that, the links would definitely change. For instance, now we are appearing in the third page. If you are trying to look into RBVRR, it appears in the third page, for instance. Now the moment you start clicking on it and more number of people are trying to click on that what particular web page, within no time it will start appearing in the second page. Later on, subsequently, when we have more number of hits to that page, and then you are showing some interest in trying to click on that particular web page, slowly it will increase its rank. I hope you are understanding. It will try to get to the first page. Got it? So it is basically that you are trying to endorse this. Why everybody will ask you either to press a subscribe button or click on the like button. So this basically improves, or you're trying to endorse it, trying to say that it is good. You're trying to give the details to the others that it is good. Okay, so what are you doing? You're basically endorsing it. How does this happen? Based on certain ranking algorithms. Okay, now the situation is rather different in the news groups. When we are talking about web pages and all, that is one topic. Okay, now here when you are talking about the news groups, it is basically based on certain discussion. So usually what happens in the news groups, certain news are posted and somebody is talking about it. You try to take the opinion of the author and you start discussions online. Okay, when does the discussion happen? When it is you're positive towards that particular news item, you don't say anything against it. But once you try to disagree, once you try to disagree on that particular posting, the number of uh, what the messages or the opinions will start flowing in. You're understanding this? So a typical news group posting consists of one or more quoted lines from another posting followed by the opinion of the author. Usually we try to post and then we will say about 4 or 5 people are in that discussion group. We'll say, what is your opinion? What is the second person's opinion? What is the third person's opinion? So what happens when you say, yes, I go with that, and then I don't have anything against it, then it doesn't matter. You're not going to mine on it. But such quoted responses from the quotation links, these are the ones which are creating a network in which the vertices represents the individuals who are trying to get to that link. and you want them to respond to that. Okay, respond to that. So we call it as respond to relationships. Now, the interesting phenomenon that I was quoting is that more frequently responded to the messages when they disagree. But when they are agreeing, they don't try to post any response, isn't it? Then this kind of a behavior exists in many kind of such news groups and is in sharp contrast to your web page link. There I do not have any kind of a discussion. I just like it, I'll press the like button, or I'll try to suggest that web page to somebody else. If I don't like it, I'll just simply exit. Where linkage is an indicator of the agreement or the common interest. I have certain things which are interested on that web page link, say suppose. So what do? I try to click that particular link and then go browse that website. This is what we are trying to analyze. Who clicked on what and whose interest lies where. Okay, this is what is your web page mining. Based on this kind of a behavior, one can effectively classify and partition these authors in your news groups. So which are completely, news groups into opposite camps. That is, who are giving a positive response and who are giving negative response. So if I try to form those kind of groups, I'm trying to analyze the group or the graph structure for these kind of references. Okay. I hope you have understood that, the news group mining. And then we'll come to the last topic called as community mining in multi-relational network. When you're looking into web or the web community, this attracts lot many number of people's attention. Now, they do not belong to one community, girls. They belong to different communities. One would like to concentrate on when you're concentrating on social networking sites, somebody are interested in news groups, somebody are interested in scientific literature, somebody is interested in art, somebody is interested in some other one. So a great deal of such work has focused on mining implicit communications of communities of web pages. Now, of scientific literature from the web and of the document citations. That is one example. So in principle, a community can be defined as group of objects who are sharing certain common interests or common properties. So here, community mining can be thought of subgraph identification. I won't be interested in only one thing. Maybe I'm interested in cooking and I'm interested in plants. I'm interested in scientific related one. So I am linked to three different subgraphs. So I exist in three subgraphs. Okay. Now I've taken one simple example of web page link. Two pages or the objects are related if there is a hyperlink between them. So I said these two are correlated to each other. Okay. So now a graph of web page linkages can be mined in order to identify a community or set of web pages with a particular topic. If I'm trying to focus only on one particular topic, then I'll try to get the linkages only to that. For instance, if I'm trying to buy a plant, in order to put up a plant, I need a manure, I need the soil that is related to it, or I need to find the information how to maintain that plant. How much water should I pour, whether it's an indoor plant or an outside where I can keep it directly under the sunlight. How frequently do I need to water? What is the soil proportion that I need to mix in order to put it? Then finally, I want to repot it in a ceramic pot or some other pot. So I want, see, when you are just lying in interest to one particular community, find the different links that are associated with that particular one particular link. Okay. Now, the most techniques of graph mining and community mining are based on a homogeneous graph. That is, they assume that only one kind of relationship will exist between the objects. But in reality, it is not the same. In real social networks, there are always various kinds of relationships between the objects. Now, each such kind of a relation can be viewed as a different relational network. Now, in this particular sense, we call it as multi-relations form a multi-relational social network. If it is a single one, it is a uni-relational social network. Also, it is also referred to as heterogeneous one. It is not of a one kind, but it is of a different kind of social networks. Okay. So each kind of relation may play a very distinct role in a particular task. Now I've taken a one example. I'll show you what it is. Now here, the different relation graphs can provide us with very different set of communities. Now, to find such a community with certain properties, we first have to identify which relations will play an important role in such community. So, mining will help us in order to identify such kind of a relation. Okay. Now, such a relation might not exist explicitly, but I just have to dig into it. I have to mine. So, that is, we may need to first discover such a hidden relationship before you try to find the community such as a relational network. In, for instance, you are buying a kurta and you don't wear just the kurta, you need something, a pajama, or you need some maybe a skirt or something else. So what do? You try to look into if they need a dupatta or if they need a lower, or what do they need, the accessories. I said for a kurta I want a silver jewelry. So I'll try to look into another network. So what is that? Unless and until I do some kind of a research or a discovery explicitly, I cannot find this particular network on the social media. So here we mine networks by assuming only one kind of relation. So we may end up missing out on a lot of valuable hidden community information. For such kind of a thing, mining may be adaptable in order to do the diverse information needs of the various users. I hope you're following. And this brings us to the problem of multi-relational community mining. This is where involves the mining of hidden communities on heterogeneous social networks. Usually when I click a like on one particular page, it does not end the mining there. I will have to look into what are the other things that I'm interested based on this community. Okay. So what are we doing? We are mining into hidden communities on these heterogeneous social networks. Now, we will consider a very simple example. Shruti, join now. Okay. Let us consider a simple example. Okay. In a typical human community, there may exist many relations. Now, some people work at the same place, some share the same interests, some go to the same hospital, isn't it? So, we'll take this kind of an example. Now, mathematically, this community can be categorized by large graph. If you take the nodes, the graphs, try to give the links to each one. If you take a white sheet and then write, if there are about 100 people living in one particular locality, and I try to give the link, somebody is interested in swimming, somebody is interested in cultural activities, somebody wants to have a go hit a gym, and somebody wants to go play some of sport of their interest. So what, when I start trying to give the links, it becomes a very, very large graph with the nodes representing people, and the edges will evaluate their relation strength. Maybe about 10 of them are interested. I would like to find out if they are interested in swimming. So the community of 100, if 80 are interested in swimming, why don't we provide a simple solution by giving them a facility towards what, the swimming pool, isn't it? Now, how are we getting into a conclusion that they need this? Based on the mining, isn't it? You're trying to see if there are certain characteristics where those nodes are representing the people of their relationship, because there are different kinds of relations. The edges of this graph should be heterogeneous. I'm not interested just in swimming. I'm interested even in another sport. Or I would like to have an indoor gym. Or I would like to have something else. Okay. I would like to have a walking track inside my community. Isn't it? For certain tasks, we also model this community using several homogeneous graphs also. Why homogeneous graphs? Just in order to find out how many of them are inclined towards one particular thing. Okay. So each graph reflects one kind of relation. Suppose as infectious disease breaks out like now, and the government tries to find out those most likely to be infected. People who are in their close acquaintance will be infected, isn't it? Obviously, the existing relationships among the people cannot play an equivalent role. It seems very reasonable to assume that under such a situation, the relation works at the same place and they lives together, so they might have got affected, isn't it? This plays a very critical role. The question becomes, how can we select the relation that is most relevant to the disease spreading? So what are they doing right now? People who are staying or living together are quarantined, isn't it? So is there a hidden relationship based on the explicit relation? Yes. So the best reveals the spread path of the disease. I mean, it is so near to what we are going through right now. Okay. Now, these are all the questions that can model mathematically as a relation selection and extraction in your multi-relational social network analysis. The problem of relation extraction can be very simple, like how is in a heterogeneous social network based on some labeled example, like how the queries have been posted by the user. How can we evaluate the importance of the different relationships? If you can answer these questions, then it is easier to draw a graph, and then it is easier to extract the relationship that is existing between these heterogeneous social networks. Then, social network analysis has been attracting much attention in the recent years. Why? Because community mining is one of the major directions in social network analysis. So most of the existing methods of the community mining assume that there is only one kind of relationship in the network. And moreover, the mining results are independent of users' needs or the preferences. Because here we are focusing only on heterogeneous networks. Though you want to focus on homogeneous, but it doesn't allow you because there exists lot of multiple heterogeneous networks, each of which will represent a particular kind of relationship, and each of that kind of a relationship will play a very distinct role in any given task. Okay. Now, based on all these observations that we have learned till now, that different relations have different importance with respect to a certain query. So new methods have been evolved for learning an optimal linear combination of these relations, which can best meet the user's expectations. These methods that are out of the scope of our paper, but we are just ensuring that we know this. Okay. So with the obtained relations, whatever we have to look into better performance and in order to achieve the community mining. Okay. When you look into the last slide, girls, this is what we have learned. How do we do the data collection? From the data collection, we are moving towards pre-processing of the data, where you do the cleaning, normalization, transform, then you try to reduce the data. Then you start building the social network for any. Here we have taken a telecoms customers, but there you have to look into a generalized view. This I've taken an example of the customer and the call data in a telecom industry. Then you start mining the communities which fall under homogeneous, heterogeneous, and multi-relational. Finally, you would like to predict the future community structure. Okay, what you would like to predict. Okay, this is where we have come to the end of the unit